Okay, this is the last question that we're going to go over. This is number 11. If we have two prospective parents, and prospective means that they want to be parents, they want to have kids, okay? Each of those prospective parents have siblings, and those siblings have a recessive genetic disorder. That's cool, Keaton. I like it. We're making a movie right now, though, so give me a sec. So, let's say that our prospective parents are Harry and Jenny. Jenny has a sister named Penny who has a recessive genetic disorder. Harry has a sister named Mary who has a recessive genetic disorder. So we're going to use A for our allele. So we know Mary and Penny both have to be little a because they have the recessive condition. So knowing that means that we know a little bit about Jenny's parents and we know a little bit about Harry's parents, because if we were to do a Punnett square, Penny would be right there, which means one parent had a little a and the other parent had a little a. And we know the parents were normal because Jenny and Harry are normal, because the question would have told us otherwise. So that means the parents, in order to produce Jenny, who is normal, they have to be normal as well. Okay? So this is what's going on. So we know that this is this is Penny, and these are Jenny and Penny's parents. And you could also use the same Punnett square for Harry. So this could be Mary, and one of these three would have to be Harry, and these would be Harry and Mary's parents. Are you following me? Okay, so now we want to know what's the chance that Harry and Jenny could have a child with the recessive condition. So first we have to say, what's the chance of Harry or Jenny being a carrier? Because they both have to be carriers to produce a child with this condition. So, could Harry or Jenny be the little a? No. So, we're left with these three. So we've got big, 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 little, and big, little. So out of 3 now, instead of out of 4, because we know it's not going to be little, little, we know that, don't touch the button, Isabel. Back away. We know that to be a carrier, so it would be 2/3 chance for Jenny to be a carrier. Alright? For Harry to be a carrier, same Punnett square, 2/3 chance. So 2, and then there's your 1/3 there that he's homozygous dominant. Alright, so we need both of those to happen at the same time, so we multiply. So that's going to be 4/9 chance that both Jenny and Harry are carriers. Alright? But just having Jenny and Harry as carriers, that doesn't guarantee that their children are going to have this disorder. Because when you cross 2 carriers, which we've done here, what's the chance of getting recessive condition? 1/4. So we have to take that into account. So we're going to have our 4/9 that they're both carriers times 1/4 chance that 2 carriers will produce the recessive condition. So that's going to give us a probability of 4/36, which simplifies to 1/9. Again, this is a harder problem. It's not hard math, it's hard logic. So you got to use your brains here. That does it for the practice that I'm going to give you. Now, what I want you to work on, and if you don't finish this in class, I want you to do it for homework. I want you to do on the other sheet, which says, by the way, don't use Punnett squares because they are laborious and mistake prone. You're supposed to use the rules of multiplication and addition instead. I want you to do number 1, number 2, number 6, number 7, number 12, and number 13. We're skipping the rest until you get more instruction. Alright? Have fun. You can turn it off now with the red button.
Oh, it's the red
button.